Hello everybody, welcome back to my channel. And today we'll be doing mock paper 20 MCQ with this four topic. The first one is acid base, second one acid base equilibria, third one solubility equilibria, and the fourth one halogen derivatives. So if you're tired, go to bed. Go to bed. Okay, go to bed. Rest. If you're not, enjoy the moment with me. Go grab some snacks, some hot drinks, hot tea, refreshing drinks, whatsoever. Let's enjoy this 20 MCQ together. I hope that it's not gonna lag again because I've been redoing a few times. Lag for I don't know what. Okay, so shall we start? Let's go. The first question. Okay, which of the following statement are correct regarding to kW of water? So first of all, okay, let me close all this stuff first. Okay. First of all, what's kW of water? kW of water means auto ionization of water, which means the whole H2O equation, H2O become H plus and OH minus, right? That's actually means H2O undergo auto ionization become H plus and OH minus. So the first statement I think is correct. Why? They say pKW is 40 at 25 degrees Celsius. How do I know? Okay, I'm not going to explain too in detail, but I'm just going to tell you that the first equation that comes out in my mind is pKa plus pKb is equals to pKw. And my pKw is equals to 14. How do I know my pKw is equals to 14? Because the second legendary equation comes out. This equation you confirm no one. pH plus pOH is equals to 14. If you don't know this equation, you can graduate from school already. Okay? And my 14 is actually equals to my pKw. And this comes with one condition. 25 degrees Celsius. So the first one is going to be correct. Second one, kW of water changes with temperature. That means varies with temperature law in your lecture notes. Do you agree with that? I agree. Why? Why? I'll show you the equation. H2O undergo auto ionization, become H plus and your OH minus. The equation is balanced. 八咗個 equation 去. Okay? So when I add heat, you add to the left or add to the right. To the left. I'm saying that I add heat to the water. So heat is going to be here. Am I right? So this is what reaction? Exo or endo? Endothermic. So according to Le-Chatelier, you learn in equilibrium, Le-Chatelier's principle. You shift the equation shift to the right or shift to the left. Shift to the right. Okay. So in this case, this is your H plus concentration, H plus ions, right? Does it change? Yes. My reactant here is my water. My product here is my H plus and OH minus ions. So when I added heat into H2O, my reactant increase or decrease? Decrease. My product increase or decrease? Increase. So meaning my H plus ions and OH minus concentration increase or not? Product increase, increase. So the kW of water changes with temperature. Make sense or not? Make sense? Because when your H plus and OH minus changes, your kW also changes. Why? Here is the equation that comes out. Because my kW is actually equals to my H plus concentration and my OH minus concentration. They varies directly. So you need to know the relationship between kW and their H plus OH minus ions, pH, pKa, pKb, and pKw. Ka, Kb, Kw. It's very important for you to know them. It's very, very, very important because exam will come and ask. So the next one, this very stupid. Why? pH of water decreases as temperature increases. My water temperature increases, my pH will decrease one, man. That means when you boil water in your house, then after a few minutes, your water starts boiling, then it becomes acid. Then you're drinking acid. No, water is neutral one. No such thing. So the answer will be B, 1 and 2. Okay, question 2. Okay, I know some people that can directly sub the formula inside to do a few some type of question. Okay, the H plus concentration is equals to square root Ka and then C. But I'm not going to use that method here. I'll use the understanding method, but slightly longer and time wasting, of course, time consuming, I mean. So I will be using the ice table as well as the Ka, Kb formula. So if you can do, just get here 0.2 mole of solution of weak acid. Weak acid is very important. In the question, need to know whether the acid is weak or strong. Okay. Here it says concentration of weak acid is 0.2. The pH of this weak acid is 3. Okay. What is pKa? They're asking for pKa. So you must know that. Okay. Ka. Sorry, let me tell first, just in case you don't know. What does the P means? Usually we just mention Ka, okay? But the P here just means that negative log. That means if they say negative, if they mention pKa means negative log Ka. If they mention Ka means Ka, okay? So we find the Ka first off, right? And then after that with negative log Ka, then we get pKa already lah. So Ka, you must know that no matter what, Ka, Kc, Ka, Kb, Kc, Kw, the formula is only one. Concentration of my product divided by my reactant. Okay, so what's my product here? Do I know? I don't know, but it says weak acid. So weak acid, it will sparingly soluble in water or partially soluble or partially ionizes in water, I should say, sparingly ionizes in water. So it's not completely. So definitely got calculation for you. H plus A minus. So here, our product is definitely concentration of H plus and concentration of A minus. And our reactants definitely is going to be HA lor. Okay, so let's apply the ice table here. Ice table says what? At first going to be 0. Then x plus x. If there's 2 here, then you put 2x lor. But coefficient nothing just x. So I realized that H plus is x. A minus is also x. So agree or not, since both of them are x, it's going to be x here. Right. So let's see whether if they give us any value here to solve for. pH is 3. They didn't give concentration of H plus, but they give pH. Can we use the pH to find the concentration? Yes. Okay. How? Let's write the pH formula first. pH equals to negative log H plus. Can the pH value given here is 3. Negative log my H plus. I can find my H plus. So after I find my H plus, I can sub into here on top. So let's find the H plus first. My H plus concentration, what is it? So let's do a negative log, shift log thing. Shift log, remember to put negative 3. So you'll get 1 times 10 power of negative 3 as your answer. Hey, please don't lag, please don't lag, please don't lag. Okay. So this is my H plus. And since my H plus is X, my A minus is also X, they are the same thing. So what I'm going to do is I'm going to square this thing in my calculator. That means 1 times 10 power of negative 3 times 1 times 10 power of negative 3. And then, do I have my H plus HA value? Yes, 0.2 mole of my solution of weak acid HA. I got the molarity, concentration. So I just directly divided by 0.2. So I get 5 times 10 power of negative 6 as my answer. So, wait, not yet. They're asking for pKa, negative log Ka. So you need to negative log answer first. What do you get? You get 5.30. So the answer will be baby. Nice. Question 3. What is the H plus ion concentration in mole per dm cubed? What is the H plus concentration ion? That means they are finding H plus concentration in 0.2 of my nitric acid. Okay, this is very important. I'm gonna erase this thing first. Okay, strong acid. The moment when you know that it's a strong acid, HNO3 is a strong acid, what you need to know is the properties. It ionizes completely in water, right? Okay, so when it ionizes completely in water, that means their equation here. Sorry, if this is weak acid, just now this is weak acid, right? So the equation here should be reversible. However, for strong acid, it's gonna be one direction because they are strong. They ionizes completely. But for weak acid, they ionizes partially. So come back, go and come back, happen at the same time simultaneously. So acid completely ionizes in water to produce H plus ions and O3 minus. So since it's completely ionized in water, agree or not, the concentration here is gonna be the concentration of an H plus ion. So 0.2 means what? Means C lor, because 2 times 10 power of negative 1, you move in one step only 0.2 lor. That's the answer. Nothing much, nothing much. Okay. Question 4. What is the Ka value? They're asking for Ka value for 0.1 molarity of an acid HX if concentration of hydrogen ion. Concentration of hydrogen ion is this. They want the Ka value. But I also know that the HX value is, I don't know it's strong or weak, but I know that they given 0.1. So first of all, I know that I can starting with the Ka formula lor. And then here's on top is gonna be my product, below denominator is gonna be my reactant. So I know that my reactant here is 0.1, right? So I just gonna put 0.1. However, do I know my product yet? No. Can I write the equation? Yes. If you are power enough, you can just skip this step. H plus, X minus. So I know that there's two things. So here is gonna be my concentration of H plus. This is my concentration of X minus. So given the hydrogen ion, concentration of hydrogen ion given what is 5.0 times 10 power of negative 4 watt. So can I sub in? Yes. But one thing, if I sub this in, the whole equation got two unknown, you cannot solve, right? So you want to know that whether if your X minus is also equals to your H plus ion, what do? Apply ICE table. But again, you can do with the formula method if you are comfortable with it. That's even more faster. But here, understanding wise, I'm not gonna do that. Okay, so ICE table at first gonna be 0, 0, okay, and then plus x. At the end, you know that it's balanced, so it's gonna be ended up with xx. It's the same more. Both are x. That means their value are the same. So again, like the previous question, 5.0 times 10 power of negative 4, you square it. Okay, and you'll get this value. And then you divide it by 0.1. Then, yeah, they are not asking for pK, they are just asking, okay, you no need to negative log. Okay, so it will be 2.5 times 10 power of negative 6. Woohoo! Answer is D, boy. Good. Question 5. Consider the three acids HF, HSO4, H2PO4 negative. Okay, so the very important concept here is I'm going to tell you. Okay, wait, let's read the question first. Sorry. Which list includes only the conjugate base? Okay, so when you notice conjugate base, conjugate acid, the first thing comes into your mind should be the one who mentioned this theory. Who is that? 3%. Arrhenius, Lewis, Bronsted. Bronsted, the answer is Bronsted-Lowry theory mentioned this conjugate acid base. So this is being said from our Bronsted-Tagore. Okay, our Bronsted-Tagore. This is from our Bronsted-Lowry theory Tagore. Okay. So when you remember his theory, you also need to remember what he mentioned about acid and base. So in this case, Bronsted theory and Arrhenius mentioned the same thing. What is the same thing? They mentioned that your hydrogen ion, okay, acid, they lose your hydrogen ion, but they gain electron. Base, okay, they gain hydrogen ion, they lose electron. Okay, but I'll just briefly explain about Arrhenius lah. Okay, Arrhenius is just basically mention how acid base acid dissolve in water like that. So they call it H plus, but more precisely in Bronsted-Lowry theory, they mentioned H plus in terms of proton. That means they don't talk about H plus hydrogen ion. Instead, they mention about proton. Okay, they mention about proton. H plus for them is proton, for Bronsted-Lowry is proton. Okay. And for Arrhenius theory, there is a limitation where they cannot explain like NH3, okay, NH3, those kind of special substance. What happened? Why they cannot show acidity? How, according to their structure, their formula to explain their properties. Arrhenius failed to do that, okay? But Bronsted theory, yes, they mentioned many stuff. And Lewis is gonna be different. Lewis for Arrhenius and Bronsted theory, acids gonna donate hydrogen ion and gain electrons. However, for Lewis theory, instead of for Lewis theory, acids they don't lose electrons. However, they gain electrons. So whoever gain electrons, according to Lewis, that's gonna be acid. Whoever whoever lost electrons is gonna be considered as acids for Arrhenius and Bronsted theory. Sorry, if it's a bit confusing, you can just replay, okay? Oh, so here, just remember that Arrhenius, Bronsted-Lowry, acid is gonna lose hydrogen. For your Lewis, acid is gonna gain hydrogen, okay? So here, since we know that acid is gonna lose hydrogen ion, okay? So here, 3 given acid. So HF lose hydrogen ion, no? So it will be H plus F minus, you gain 1 electron. Okay, so which one is your conjugate base? Here's the acid, this is gonna be your conjugate base, your F minus is gonna be your conjugate base. Is that okay? Yeah. Next, HSO4, I want to be faster. So lose hydrogen ion. What happened is SO4, 2 minus, lose hydrogen ion, gain more electron, according to Bronsted-Lowry theory. Okay. Next, H3PO4. Lose 1 hydrogen ion, you get H2PO4 minus A minus A. Wait. H3, oh, no wonder, 怪怪的. Sorry, I forgot to put the minus here. So you lose 1 hydrogen, you gain 1 electron. So here you're gonna be 2 minus because here already got 1 minus. Sorry, mistakes. So this is my conjugate base. This is my conjugate base. This is also my conjugate base. So answer will be, let's find it, will be A. Good. Question 6, what is the pH value of, okay, they're asking for pH. They're asking for pH, okay, pH of 2.0 of my HOCl. Again, you can do the OH minus equals to square root KB over C times C formula, but I'm not going to do that, okay? So here, given Ka, okay, so I know the Ka value. I just directly sub in the formula. I assume you already know. Okay, so on top is going to be reactant, below is going to be product. So product, I got HOCl 2.0 Okay, reactant I don't know write the equation. HOCl become this is I think wait, is this I think this is weak acid. So weak weak acid. Strong or weak okay, never mind, not important. So H plus OCl minus. Okay, here apply the ice table. Okay, if I'm not mistaken, this is strong acid, right? Jialat, my brain cannot work. Okay, 0 0. I think this is weak acid. Sorry, weak acid. Okay, so here at first 0 0 and then plus x and then x. Okay, so both of them same so x, I'm just gonna put x lah. Not gonna, you know what it means, right? Since they are both the same thing, just replace them with x. So what it will turns out is gonna be x times x gonna be x squared 2.0 and then just substitute this thing. I mean, just put it back. It will be like this, copy and paste. Okay, so can you solve the equation? Yes. So 3.5 times 10 power of negative 8. Okay, and then times 2.0. And then remember to square root your answer. And then you will get your x as 2.65 times 10 power of negative 4. They are asking for pH. Wait, They're asking for pH, so you don't be scared. Look the question properly. pH. So what is this? This is my H plus value. How do I know? Yes, this can be my OCl minus value as well. But you need to know that my OCl minus also X. My H plus value also X. So either both also 2.65 times 10 power of negative 4. So if I need H plus here, do you agree that my H plus value is also equals to 2.65 times 10 power of negative 4? Yes. So pH, okay, is equals to negative log H plus. So I'm gonna negative log my answer lah. So I'll get 3.56, 3.58, sorry. So 3.58 or not? Nah. C lor. Answer is there. C. Next, consider the following acids are. Okay, HF, HOCl, and H4 lah. Which of the following is ordered from, please student, read the question carefully. Well, I have made that stupid mistakes before. I lose the marks. So don't do the same mistakes that I did. It's not that you don't understand. It's just that you are blurred enough to make that mistakes. Weakest to strongest. I want the weakest to the strongest. Then you give me the weakest to strongest. Here, how do I know whether it's weak or strong? They're not giving me the pH value. Instead, they give me the Ka value. So you need to know the first legendary equation that comes into your mind should be the higher the Ka, the more the acidic the substance. But your Ka value is going to be totally opposite with your pKa value. That means the higher my Ka, the lower my pKa. That also means that the lower my pKa, the higher the more acidic the substance is. You need to know the relationship of these are. Okay, good. So here they only give us Ka, so no worries. We don't need to care about pKa. It's very good because the higher the Ka, the more the acidic, right? So don't look at the value here. Okay, look at the value here first. The power, because the power already tells you. But if you get the same power, then you look at the value in front. So here, negative 10, of course, is the smallest one. No? Negative 4, of course, is the highest one. No? Right. The highest one, that means the highest Ka value. Lo, and this one is the middle. Lo. So the answer will be NH4 first, and then HOCl, and then HF. The answer will be B. Lo. Done. Let me drink some water first. You know. Which of the following is amphiprotic? Amphiprotic means what? Amphiprotic means a substance that can act as acid and also act as base at the same time. It's like, you have some kind of friends, right? They treat you very nice, and then behind they tikam belakang, two-faced kind of people. They're amphiprotic. Okay, so here the answer would be why? Because for me, right, I just refer to my notes and then I just remember a few amphiprotic substances. For example, NH3, NH3, H2O. They can act as acid and base at the same time. Why? Let me show you. So HCO3. So if you are acid, you lose hydrogen, right? According to Bronsted-Lowry theory, this is mentioned in Bronsted-Lowry theory. So what happened? H plus CO3 minus. Am I right? Here, if HCO3 base, I gain hydrogen, right? What will I become? H2CO3. You see this thing? This is what it means by amphiprotic substance. But for HCl, if I try to do it right, it will just become H plus and Cl minus. And then if I do it this way, you see, it got this thing on me. You ever found this thing in your book or in your syllabus? No, I don't think so. You have never learned that before, then You don't even have to look at it sometimes. This is like the skills of studying. Yeah. Okay. So yeah, lah, a simple example that the question 8 is B. Okay. So question 9, let's go to question 9. So when NH3AQ is titrated with HCl, okay, with HCl, what is the pH of the equivalent point? Okay, so NH3 is titrated, that means NH3 is analyte law. Okay, HCl is what? HCl is my titrant, sorry. Titrant. Is it titrant, right? Yeah. So they're asking for the pH of the equivalent point. This is just very simple. Since your analyte is NH3 and saturation of HCl, the pH value of the equivalent point. So what do we need to do here first is that we need to be careful of what substance they use. So in this case, NH3 is a weak base. HCl is a strong acid. So, you know, weak base and strong acid, their reaction, the pH at the equivalent point is going to be more less than 7. Why? Because strong acid. Strong acid, and then here weak base. So strong acid, eventually the equivalence point of your pH is going to be more to acid part law. So it's going to be less than 7. Nothing much. Next, which of the following is the correct equation when a small amount of hydrochloric acid, HCl, is added to the CH3COO and A and then CH3COOH buffer? So this buffer, as you can see, it's a ethanoic acid, weak acid. Okay, so let's see which equation makes sense. Let's try to guess the answer. CH3COOH plus Cl and then become HCl CH3CO minus A. I don't think it's correct. No. How about this? HCl then plus OH suddenly plus OH and become H2O. It's not even related to your buffer. No. This one, H plus CH3COO, and then you get CH3CA. Makes sense, what? How about this? H2O again, not even talking about buffer. So question answer will be C. Question 11. Why does the addition of small amount of acid to a mixture of aqueous solution of ethanoic acid and this salt have little effect on the pH? Okay. H3O plus. Okay, what's H3O plus? Actually, your H3O plus, right, is your H plus. It's just different name. And this is more real life application. But it's the same thing, okay? You can write in both way in exam. It's acceptable. It's accepted. In buffer, H3O plus ions in buffer solution inhibit the ionization of HCl. I don't think so. The CH3COO minus ions in the buffer solution reacts with H plus ions from HCl. This one correct? Makes sense or not? CH3COO react with my H plus ion to form HCl. From the HCl. Makes sense? Correct? That's what happening. The quantity of hydrogen ion produced by the CH3COOH approximately equals to hydrogen ion produced by the HCl? No. Why do you need to relate their concentration here? No need. This is even funnier. The volume of the solution is not increased to a significant extent. No. So the answer would be, yeah. Question 12. In an experiment, KOH, okay, is titrated with CH3CO. Okay, this is a weak acid. Ethanoic acid is a weak acid. KOH is a strong base on the other hand. So which of the following is a suitable acid-base indicator for the reaction? So this is where you really need to remember what is the range between strong acid and weak, strong acid and strong acid, strong base, strong acid, weak base, strong base, weak acid. So I will tell you everything here. So for strong acid react with strong base, right? Okay, their range in the equivalent point is going to be 3.5 to 10.5. For weak acid, for strong acid for strong acid and weak base, it's going to be 3.5 to 7.5. For strong base react with weak acid, it's going to be 7.5 to 11.0. You need to remember this value no matter what. So here it is which category? The first, second, third. It is the third, right? Strong base and react with weak acid. So it falls between 7.5 and 11. So which indicator here falls between this range? You're gonna find it. So 8.2 to 10. Can inside here Okay, this one accepted. How about phenolphthalein accepted? How about our bromo crystal green? 3.8 to 5.4. Over here cannot. Methyl violet Violet 0 to 1.6 also here. Cannot. So the answer will be 1 only. Your phenolphthalein, the most famous indicator around the world. Yes. Question 13. A student tests for a presence of chloride ions in a solution by adding solution of lead nitrate PbNO3 bracket 2. And then the result is positive for white precipitate of lead chloride is formed. That means your PbCl. PbCl2, sorry. So you need to know that PbCl it's a insoluble salt, okay, but it's not like insoluble, it's totally not soluble, it's just like partially soluble. Okay, so PbCl, how do I remember it's soluble? Because I remember during SPM, persatuan bar 是 thinner. Wait. No, Curry means Cl and react with persatuan bar, persatuan agama Hindu. That means Cl persatuan agama Hindu. Cl reacted with 3 of these substances is going to be precipitate form. Okay, so the precipitate exists in equilibrium ion given you the balance equation and then give you the Ksp value. They want you to calculate the molar solubility. What is molar solubility? Molar solubility means your concentration at equilibrium point. It's your concentration, but equilibrium point. So the formula is also the same. Your mole divided by your volume in terms of the m cube. But in this case, we don't need that because we got Ksp. Again, whatever with K, product divided by reactant. So 1.6, I'll just sub in times 10 power of -5. What's my product? What's my reactant? Okay, so calculate the molar PbCl. So PbCl, they want PbCl here. So PbCl, do I know the value of PbCl? Let me put first. So if it's PbCl, my concentration ion here will be Pb2 plus and then Cl minus. But one thing, according to the formula, according to the balance equation here, 2Cl. That means I need to put a square on top. Understand? This is detail that you need to know. Don't make these mistakes in your exam. 2 here. Okay. So let's try to use the information given here. So we don't have any value. So let us find the ice table. Let's apply the ice table again. So Pb2 plus and then 2Cl minus. Okay, here got 2. The coefficient is 2. So remember, plus x. I skip the 0 part. 2x. Understand why, right? Because 2 here. Okay, I just put it. So I noticed that my Pb2 plus is x, while my Cl minus is 2x. So if I try to sub it in, it will be x and 2x square. And then PbCl2, 1.6 times 10 power of -5. And I realize something. Can I solve the part one? The top one? Yes. Let me solve first. So you 2x squared, that means you get 4x squared. 4x squared times x, you get 4x cubed. And then PbCl2 nutrition. In this case, you notice got 2 unknown. Got 2 unknown cannot solve already. I already applied the ice table. But one thing, remember that I mentioned precipitate. Precipitate means solid. And you should know in your lecture notes, in the equation, whenever it comes to solid, and you are doing this equation for K something, Ksp, Ka, or K whatsoever, whatever substance that is solid will not be included in the equation. So you can cut it off. You can cut it off. For stronger students, they already know what happens, so it's no point of writing all this. Okay? So now, since it's solid, you don't include in the equation, so this is what is left. So can you solve the equation? You can find the x. Yes, then that will be your answer. So I'll just directly find out. So first, you divided by 4 first. 1.6 times 10 to the negative 5. You don't cube root first. It's gonna, and then because after you cube root, then you divide by 4, the value is gonna be totally changed. Divide by 4 first, and then cube root your answer. I start to feel a bit hungry, and then I feel like I want to sleep already. 0.016. So your answer will be 8. Oh, sorry, in terms of mole per dm³. 14. Calculate the molar solubility of CaF2 when it dissolves in a solution containing 0.0 mole of Kf acquires. Okay, I am gonna do a bit more faster. Okay, so given Ksp, of course, I'm gonna use Kp formula again, but this Ksp for my CaF2 are 3.9 times 10 power negative 11. Given solution containing this Kf, okay, so calculate the molar solubility CaF2. So CaF2, that means you get Ca2 plus and then 2F minus, okay? And the equation here is gonna be Ca2 plus concentration F minus 2 divided by CaF2. Okay, to apply the ice table here, have to be careful. Why? Because notice that CaF2, when it dissolves in a solution, already contains of 0.02 of my Kf. That means, right, when I try to put CaF2 into my Kf, they already have 0.02 F inside. That means because the common ion, yes, this is the main point I want to mention about. The common ion here is F, okay? So when you put CaF2 into Kf, there's common ion. That means your F, the initial value of your S is not going to be 0 anymore in your ice table. It's going to start from 0.02 because when you put into Kf, the value is already 0.02 M. So here, 0.02 M already balanced, so 0.02. And then plus x, and then here's going to be x. Here's going to be, oh, sorry, here's not x, here's 2x. So here's going to be 0.02 plus 2x, 0.02 plus 2x. So because the 2x value is too small, or I should say it's a constant, the value doesn't really cause a change. So in this case, we will just assume it's 0.02. Okay? So we know that the F value here is 0.02 or sub in 0.02 square. And then Ca2 plus is x. CaF2. Again, given 3.9 times 10 power of negative 11. Okay, wait. Got two unknown again. How to solve? That means you throw this one away. Can you solve now? Yes. 0.02 square. And then 3.9 times 10 power of negative 11 divided by your answer. Your X concentration is going to be 9.75 times 10 power of negative 8. Throw away your CF2. 9.75 times 10 power of negative 8 mole per dm cube. The answer will be C. Done. Next, what is the KSP expression? This one, rubbish question. Okay, rubbish question. Unless you don't know the charge, you need to know. Cu2 plus concentration and IO3. IO3 and then 2, that means 2 IO3, right? 2, that means you put it on top. Understand, right? You understand this part, right? Okay. So so 8 minus 2 will be nothing much. It's like this is similar to like your OCl, also equals to -1. Halogen derivative already. Which of the following statement is correct for this reaction? So I notice here Cn, the main point here is your Cn. So we know that when we react to KCN, your lecture notes are when you react to KCN, why lagging one? You okay? I feel like I need to wait. Why lagging? Wait. It's lagging. Okay. Come back. KCN. So when your reagent is KCN, what you're going to produce? Nitrile. It's a formation of nitrile kind of equation. Why it's lagging so bad? Oh. Wait, let me unshare my screen for a while. Comment aside. Technical issue. Okay, KCN, formation of nitrile. Okay. So here, let's read. Halogen alkane is classified is classified as primary haloalkane. Is it correct? Let's look at the second one. The mechanism involved the formation of carboxyl ion. Hey, wait. I'm not sharing, man. It's still lagging. Bella. The second one. The mechanism involved the formation of carboxyl ion. No, it does not. The rate of reaction will increase by increasing the concentration of the halogen alkane only. No, also. So the answer will be first one. Okay. So here, right? I would say that during KCN is a formation of nitrile. So what happened is halogenal alkane is classified primary. Halogenal alkane is here. See H, and Br. Here is your R group. That means your alkyl group. So you only have one alkyl group. That means it is your primary halogenal alkane. If you got two alkyl group, that means you got two. That means you are secondary halogenal alkane. If you got three left, tertiary halogenal alkane. So in this case, it's first. And here also one. Right or not? So one R group, primary halogen alkane. 17. Compound X is heated. Please don't like. Compound X is heated with NaOH. Oh, NaOH. Remember, when you saw NaOH, don't be so happy to just finalize it's a hydrolysis. No. Be careful of the aqueous there. If it's aqueous, that means it's hydrolysis. If it's ALC there, it's not hydrolysis. It's not, okay? That one is elimination. So here, compound X heated with NaOH aqueous, that means this is hydrolysis. Then reacts with AgNO3 to give a pale yellow precipitate. Which of the following is compound X? It's gonna be CH3CI. Whenever these are tricks. Whenever you see I, it's gonna be yellow precipitate. Not necessary precipitate, but it's gonna appear yellow. Okay. So next, so yeah. Do you need further explanation? Okay, just know that this hydrolysis, when this NaOH reacts with AgNO3, it will produce CH3Cli to give a pale yellow precipitate. The real yellow precipitate is just this. For me, I remember that yellow precipitate is gonna be this. Okay. Okay, question 18. Which of the following is increasing order of SN2 reaction? So you need to know what does it mean by increasing order of SN2 reaction. No? So SN2 reaction, the first legendary thing that comes to my mind is bulky group. What does bulky group means? That means R group. Your RQ group. When you have many alkyl groups, that means your carbon is surrounded by maybe 2 or 3, consider as many alkyl groups already, to form your tertiary, secondary halogenal alkane. We call those R groups, alkyl groups, that's blocking the way that's surrounding the C bulky group. They are blocking other substance to react with the carbon in the middle. That means like this. when I have like, for example, when I have Cl here minus here, I want to react. These are my bulky groups that is blocking me to react with my carbon. Am I right? So yes, this is what it means by bulky groups. So the reactivity starts from that, meaning the lesser the bulky group or the R group, RQ group, the more the reactive. Because why? It's easier for other substance to bind with the carbon there. This is what I remember. So we need to see which one have the highest R group, RQ group, more bulky group. That means there will be the least reactive, and the least, and those that have the lesser R group, RQ group, then most reactive. So if you don't know, right, you can just write out. So CH2, and then bind with Br. This for the first one, okay? And then those are just R group. These are H. So this is what? Only one R group. That means this is primary halogenal alkane. So this is primary halogenal alkane. The first one. Second one, got 3 CH3. Already mentioned got 3 CH3. Okay, 3 CH3. That means got 3 R group lor. CH3 R group. So this one is tertiary. Second one, don't know. Draw it out. CH3. H. And then the second carbon is bonded with Br, and then below is H. And then others is CH whatsoever. That means your R group. So how many R group here? This is one R group. This is one R group. There is 2 R group here. That means for this substance, it's going to be secondary halogenal alkane. So they said increasing order, right? So from the most to the least. So 2, 3, 1. So 2, 3, 1. 2, 3, 1. So 2, 3, 1 will be C. 2 more questions, then ciao. What's the reagent for this reaction? I see OH minus. Then I know that it's NaOH. But whether it's aqueous or AQ, now I need to decide. Whether it's AQ or alcohol, now I need to decide. Hey, please don't lag, please don't lag, please don't lag. Show some bye for please don't lag. It's taking so much time already. My God, it's taking so much time already. Okay. Okay. Now I need to decide whether it's aqueous or alcohol, right? So here, I would say hydrolysis, you will notice the OH in your equation. This is my technique. But when it comes to elimination, where it uses NaOH, alcohol, you won't see OH in your equation. Because, for example, and then elimination will form alkene. Okay, for example, I have this substance. This is Cl, this is H lah. H. So when I add NaOH alcohol, right? What happened is the OH, it won't go here. But the NaOH alcohol instead, what they do is they will form double bond by taking away your Cl minus and then your H plus. Then here become double bond. But their OH do not join with combine with any part here. However, so you form, elimination, this is elimination, and you will form double bond. But you erase everything. If you are talking about NaOH in water aqueous, it's a different case. Your OH undergo nucleophilic substitution reaction because your OH minus is nucleophile, which is going to combine with your carbocation ion. Understand? Then it will become something like COH, something like that. Yes. This process is known as nucleophilic substitution. So I will conclude is NaOH aqueous is hydrolysis, and then it uses nucleophilic substitution For alcohol, for NaOH, it is elimination. And then it doesn't use nucleophilic substitution. It will give you alkene. And your alkene might appear to be cis and trans. Yeah, this is what I know, and I'm gonna put it out for you. So in this case, it's in your equation, right? NaOH aqueous. Okay. Last question. Which of the following compounds will react most rapidly in hydrolysis? What's the reagent NaOH in terms of aqueous? Okay, here it's gonna be answer D. How do I know? Okay, because I will say that here I will explain your bond length affects your bond strength. So the higher the longer the bond length, the lower the bond strength. Okay, when the lower the bond strength, the higher the reactivity. Agree? Because it's more easier to break ma. So in this case, CH3I has the longest bond length. However, CH3F has the shortest bond length. So talking about CH3I, since it has such a long bond length, that means their bond strength is gonna be weak. So when their bond strength is weak, it's easier to break. That means more reactive. And then another method to remember is, according to your group 17, since it's halogen, right? So your reactivity increases up the group, am I right? Fluorine is the most reactive, ma. But when it combines with R group, RQ group here, it's gonna be opposite. That means going down, your reactivity increases. This is also one of the methods, remember. Okay, so that's all from me. Thank you so much for joining 20 MCQ to me. I know it's a bit long because I mentioned too much. I think too much about the lecture notes and stuff. Maybe I'll be more faster next time. Thank you guys for watching, and yeah, hope you subscribe my channel. Bye bye.